My name is Eldri Albisli Anak Hirakong.
My name is Aubrey Robert.
Table of content, that is question 1, question 2, question 3, question 4, and ethical consideration, and lastly reference. Question 1. Given Q equals to 1.8 meter cube per second, N equals to 0.013, D equals to 1.2 meter, and we have to find S. The equation is Q equals to A times 1 over N times RH power of 2 over 3 times S power of 1 over 2. First, you have to find area, and I'm going to use pi d square over N, and you will get the area, that is pi times 1 over 2 square over N, and the answer is 0.565 meter square. After that, you have to find P, and I'm going to use pi d over square, and that is pi times 1.2 over 2, and you will get 1.884 meter. After that, you have to find RH, that is A over P. Insert the A and P, and you will get 0.300 meter. After that, from the equation the first, we have to find the S, that is 1.8 equals to 0.565 times 1 over 0.013 times 0.300 power of 2 over 3 times S power of 1 over 2. And then calculate the A times N times RH, and you will get 19.477. After that, the 19.477 go to the side, and you will get the 1.8 over 19.477. After that, it will become 0.092. To find S, the power of 1 over 2 go to the right, and it will become 0.092 power of 2 over 1, and S equals to 8.464 times 10 power of negative 3, or 0.0085. Question 2. Given N equals to 0.012, Q equals to 10 meter cube per second, S equals to 0.0005. Width equals to 5 meter, and the Z is 3 over 2. To find Z, we have to cross multiply, and it will become 0.67. And then we have to find area of trapezoidal, that is y times b plus zy, so it will become y times 5 plus 0.67y. After that, multiply the y inside the bracket, so you will get 5y plus 0.67y squared. So that is your first equation. After that, you have to find p, that is b plus 2y square root 1 plus z square. Insert the b and z, so you will get 5 plus 2y square root 1 plus 0.67 square. And then we have to solve the z, that will become 5 plus 2y square root 1 plus 0.449. After that, we have to solve the square root, and it will become 5 plus 2y times 1.204. And then the 2y, we have to multiply inside the bracket, so you will get 5 plus 2.408y. So that will be your second equation. After that, we already find a and b, so insert the a and b inside the equation of RH. So you will get 5y plus 0.67y squared over 5 plus 2.408y. After that, you already get RH. So inside everything from the equation, that is q equals to a times 1 over n times RH over RH power of 2 over 3 times s power of 1 over 2. So it will become 10 equals to 5y plus 0.67y squared times 1 over 0.012 times 5y plus 0.67y squared over 5 plus 2.408y power of 2 over 3 times 0.0005 power of 1 over 2. And then solve the n and s, and it will become 10 equals to 5y plus 0.67y squared times 83.33 times 5y plus 0.67y squared over 5 plus 2.408y power of 2 over 3 times 0.0224. After that, multiply the number that have no y, so it will become 10 equals to 1.867 times 5y plus 0.67y squared times 5y plus 0.67y squared over 5 times 5 plus 2.408y power of 2 over 3. After that, the 1.8 go to the 10, and it will become 5.356 over 5y plus 0.67y squared times 5y plus 0.67y squared over 5 plus 2.408y over power of 2 over 3. After that, we have to trial and error method. From the table, I'm using 1.2 for the y, and I will get the q is 6.857. After that, I'm use 1.07, and the q I get is 5.304. And I choose again 1.075, and I get 5.345. And for the last one, I'm choosing 1.078, and the q is 5.366. So I'm using the y equals to 1.068 meter because it near of the 5 near on the 5.356. Yes. And to find the water depth y for base hydraulic trapezoidal cross section, we have to use the b plus 2zy equals to 2y square root 1 over z square. So insert everything, and you will get 5 plus 2 times 0.67y equals to 2y square root 1 plus 0.67 square. After that, for the left, you get 5 plus 1.34y, and for the right one is 2y times 1.204. After that, for the right one, multiply the 2y inside the bracket, and you will get 2.408y. After that, from the left, the 1.34y on the left, you have to change it into the right, so you will get 5 equals to 2.408y minus 1.34y, and you will get the 5 equals to 1.068y. After that, multiply it, multiply the 1.068 to the 5, and you will get y, that is 4.682 meter.
So for question 3, it is given to us that the value of velocity is 9.5 meter per second and the depth is 1.2 meters. So for question A, we will be using the formula y plus E equals y plus v square over 2 times gravity. So by putting all the values, we will get the answer 5.7.9 5.7999 meters. Next question is B. We will use the formula yc equals q square over g powered by 1 over 3. The steps below is the ways to find q. So we can conclude that q small q equals to q over b, which also equals to vy. So we will get the value equals to 11.4 meter square per seconds. So we will use this answer to put in the previous formula. So we will get yc equals 11.4 square over 9.1 powered by 1 over 3. So we will get the answer 2.366 meters. For the alternative the formula, we will use E equals y plus q square times over 2 times y square over times gravity. So by putting all the amounts that we have calculated before, we will get the answer E equals to 5.999 meters. So by using the the trial and error method in the table, we can see that the closest amount that we can get is 5.587 meters. So the next question is the C for finding the whether is the flow is subcritical or supercritical. So we will be using the Froude formula equals to V over square root of gravity times y. So the answer will be 2.769, and it is more than 1, so it is supercritical. The next question is D. So in this question, we need to find the energy minimum energy. So the formula we'll be using is 3 over 2 times yc. So the final answer will be 3.4549 meters. So the final step is to find E, the critical velocity. So we'll be using the formula Vc equals square root of gravity times yc. So the final answer will be 4.818 meter per second. As you can see, this is the graph, and we can conclude the final answer that y is lower than yc, so it is supercritical flow, and Froude is more than 1, so it is supercritical flow. Thank you. So for question 4, we are given B equals 3 meters, Q is 5.6, S is 0.0005, H is 0.025. So we need to find four things, which is A, determine the depth after the jump, B, calculate the energy loss, C, determine the power loss, D, identify the type of jump. So for A, we'll be using the formula for Froude equals V over square root of G times Y. For the depth 1 or y1, we will be using negative y depth 2 or y2 over 2 plus square root of y2 square over 4 plus 2v2 square times y2 over gravity. And for the formula for q, we'll be using the usual formula, which is a times 1 over n times rh2 over power by 2 over 3 times s power by 1 over 2. So by doing the calculations for a equals by, so we will get the 3, we will get 3y. For p, we will get p equals 3 plus 2y. For rh, then we will get 3y over 3 plus 2y. So let's put it in the q discharge equations. So um, by putting all the amounts in the formula, we will get um, we will put the answer to determine by using the trial and error table, which we can get the depth after the jump y equals to 2.241 meters. So the next step is putting all the value we have calculated into the formula. Yc equals q2 q square over 1.81 power by 1 over 3. So how we get the q for this formula? It is q over b equals 5.6 over 3. So the q will be 1.867. So put in the value in the formula, we will get yc equals to 0.708 meters. So we can conclude that yc is lower than depth after the jump, or y2. So the next step is using the formula y1. But before that, we need to find v2. So by using the formula q over a, we will get 5.6 over by2. So the final answer for v2 is 0.833. So put it in the equation, the formula for y1, we will get the final answer 0.133 meters. So we can determine that y1 is lower than yc. So it is concluded that it is supercritical. So the next step is to find the energy loss. So by using the formula y2 minus y1 time power by 3 over 4 times y2 times y1. So the final answer will be 7.857 meters. So for C, we will be finding the power loss. So the formula for power loss is gravity, the density times gravity times Q times energy loss. So putting all the amounts that we have calculated, we will have the final answer, which is 43,000 431,600 633.72 watt. So the final step is to find the D, which is fraud. So we'll be using the formula V1 over square root of gravity times Y1. And how to find the V1 is by dividing 5.6 with 3.0 times 0.133. So we'll be get the answer for V1. The amount for V1 is 14.035. So putting it into the fraud formula, we will get the final answer 12.287, which we can conclude that fraud the fraud value is higher than 9, and it is a strong jump. Thank you.